Welcome, future coders and tech enthusiasts, to Unlocking the Code, your definitive guide to navigating the often bewildering world of programming languages. If you've ever wondered which language to learn first, or which one best suits your ambitious project ideas, you've absolutely come to the right place. Today, we're diving deep into some of the most popular and influential languages out there, breaking down their strengths, common uses, and what makes each one unique. Think of this as your personalized roadmap to finding the programming language that truly clicks with you and your goals. The journey into programming can seem daunting, like staring at a cryptic puzzle with a million tiny pieces. But trust me, with a little guidance, it's more like discovering a superpower. Each language offers a different way to build, create, and solve problems, from crafting beautiful websites to developing complex AI. We'll explore the gentle learning curve of Python, the web-weaving magic of JavaScript, the enterprise-level power of Java, the raw performance of C++, and the elegant simplicity of Ruby. Our aim is to demystify these tools and empower you to make an informed decision about where to start your coding adventure. So grab a coffee, get comfortable, and prepare to have the complex world of programming languages made simple. We're not just going to list facts. We're going to explore the personality of each language, helping you understand not just what they do, but why you might choose one over the other. By the end of this video, you'll have a clearer picture of the landscape and hopefully a spark of inspiration for which path to take. Let's get started on this exciting journey together and figure out which programming language is your perfect match. Alright, let's kick things off with Python, a language that's often hailed as one of the best, if not the best, for beginners and for very good reasons. Its syntax is famously clean and readable, almost like writing in plain English. This design philosophy significantly lowers the barrier to entry, meaning you can spend more time understanding programming concepts and less time wrestling with complicated punctuation or structural rules. Imagine trying to learn a new spoken language. Python is like starting with one that has a very logical grammar and shares many words with your native tongue. This makes the initial learning curve feel less like a steep climb and more like a gentle, inviting slope. One of Python's most significant strengths is its incredible versatility. It's not just a one-trick pony, it's more like a Swiss Army knife for developers. You'll find Python powering a vast array of applications from web development with frameworks like Django and Flask to data science, machine learning, and artificial intelligence. Its extensive collection of libraries and frameworks means that for almost any task you can imagine, there's likely a Python tool already built to help you achieve it efficiently. This wide applicability means learning Python opens up a multitude of career paths and project possibilities, making it a truly valuable skill to acquire in today's tech-driven world. When we talk about beginner friendliness, it's not just about the syntax. Python boasts a massive and incredibly supportive global community. Stuck on a problem? Chances are someone has faced it before, and there's a solution or helpful advice waiting for you on forums like Stack Overflow, Reddit communities, or dedicated Python discussion boards. This community support, coupled with abundant high-quality tutorials, documentation, and online courses, creates a rich learning ecosystem. You're never truly alone when learning Python. There's always a resource or a fellow learner ready to help you navigate through challenges, which is incredibly encouraging. Delving deeper into its applications, Python's role in data science and machine learning is particularly prominent. Libraries such as NumPy for numerical computation, Pandas for data manipulation and analysis, Matplotlib, and Seaborn for data visualization, and scikit-learn for machine learning algorithms are industry standards. These tools empower developers and scientists to process vast datasets, uncover insights, build predictive models, and drive innovation in fields ranging from finance to healthcare. If you're fascinated by the idea of making sense of data or building intelligent systems, Python is an almost indispensable language to have in your arsenal. For web development, Python might not be the first language that comes to mind for front-end tasks, but on the back end, it's a powerhouse. Frameworks like Django provide a high-level, batteries-included environment that encourages rapid development and clean, pragmatic design. Flask, on the other hand, is a micro-framework offering more flexibility and control for smaller projects or for developers who prefer to choose their own tools. Many well-known websites and applications, including Instagram, Spotify, and Netflix, utilize Python in their tech stack, testament to its capability and scalability in handling complex web services. Beyond these major areas, Python also shines in scripting and automation. Its simplicity and the ease with which you can write scripts to automate repetitive tasks make it a favorite among system administrators, DevOps engineers, and even scientists who need to automate experiments or data processing pipelines. Whether it's organizing files, scraping data from websites, or managing system configurations, Python scripts can save countless hours of manual effort. This practical utility adds another layer to its appeal, as you can start applying your Python skills to real-world problems relatively quickly, providing a satisfying sense of accomplishment. The readability factor of Python, often emphasized, has profound implications beyond just learning. In professional software development, code is read far more often than it is written. Python's clean syntax makes code maintenance easier and collaboration more efficient. When team members can quickly understand each other's code, it leads to faster development cycles, fewer bugs, and a more sustainable code base over time. This emphasis on clarity is a core tenet of the Python philosophy, often summarized by the Zen of Python's aphorism, readability counts. Moreover, Python is an interpreted language, which means code is executed line by line. This often makes debugging easier for beginners, as errors can be pinpointed more directly. While interpreted languages can sometimes be slower than compiled languages like C++ or Java for computationally intensive tasks, Python's performance is more than adequate for a vast majority of applications, especially when optimized or when performance-critical parts are written in C or C++ and integrated with Python. Plus, the development speed often outweighs the slight performance trade-off. Looking at its ecosystem, the Python Package Index, or PyPI, hosts hundreds of thousands of third-party modules which you can easily install using a package manager called pip. This vast repository means you rarely have to build everything from scratch. Need to work with APIs? There's a library for that. Need to create a PDF? There's a library for that. This rich ecosystem accelerates development and allows programmers to stand on the shoulders of giants, leveraging existing well-tested code to build new and innovative solutions. In summary, Python's gentle learning curve, its remarkable versatility across diverse fields like web development, data science, AI, and automation, coupled with a strong community and an extensive set of libraries, makes it an exceptional choice for your first programming language or a powerful addition to any experienced developer's toolkit. It's a language that grows with you, from writing your first simple script to building complex, scalable applications. Its continued popularity and widespread adoption suggest it will remain a key player in the tech landscape for years to come, making it a wise investment of your learning time. Now let's shift our focus to JavaScript, a language that is absolutely fundamental to modern web development. If you've ever interacted with a website that does more than just display static text and images, think drop-down menus, animated graphics, live content updates, or interactive forms, you've experienced JavaScript in action. It's the language that breathes life into web pages, transforming them from passive documents into dynamic, engaging user experiences. Without JavaScript, the web as we know it today simply wouldn't exist. It would be a far less interactive and much more boring place. Originally conceived as a lightweight scripting language to add interactivity to Netscape Navigator in the mid-90s, JavaScript has evolved dramatically. It's now a fully fledged, powerful language that runs not only in web browsers or client-side, but also on servers or server-side, thanks to environments like Node.js. This expansion means that with JavaScript you can potentially handle both the front-end user interface and the back-end logic of a web application, making it a cornerstone of full-stack development. Its ubiquity across the web stack is one of its most compelling features. The primary role of JavaScript in the browser is to manipulate the Document Object Model, or DOM. The DOM is essentially a tree-like representation of a web page's structure, and JavaScript can add, remove, or change any of the HTML elements and CSS styles on the page in real time, based on user actions or other events. This capability allows for things like validating form inputs before submission, creating image sliders, displaying pop-up messages, and dynamically loading new content without needing to reload the entire page, which is key for smooth and responsive user interfaces. One of the reasons JavaScript has become so dominant is its ecosystem of frameworks and libraries designed to simplify and accelerate web development. You've likely heard of names like React, developed by Facebook, Angular, backed by Google, and Vue.js. These frameworks provide structured ways to build complex user interfaces, manage application state, and create reusable components. They abstract away much of the low-level DOM manipulation, allowing developers to focus on building features and creating sophisticated single-page applications that feel like native desktop or mobile apps. Beyond the front end, Node.js has revolutionized what's possible with JavaScript on the server. It allows developers to write back-end services, build APIs, and interact with databases using the same language they use for the front end. This can lead to more streamlined development workflows and allows teams to specialize in a single language across the entire application. Node.js is known for its non-blocking, event-driven architecture, which makes it highly efficient for building scalable network applications, real-time chat applications, and microservices. JavaScript is also an interpreted language, like Python, meaning it's typically executed directly by the browser's JavaScript engine, like V8 in Chrome or SpiderMonkey in Firefox, or by the Node.js runtime. This makes for a relatively quick development cycle, as you can often see the results of your code changes immediately by refreshing your browser. While this used to come with performance concerns, modern JavaScript engines are incredibly optimized and can execute code very quickly, making JavaScript suitable for a wide range of demanding applications. The language itself has evolved significantly over the years, with the ECMAScript standard, which is the specification JavaScript is based on, receiving regular updates. These updates introduce new features, syntax improvements, and capabilities that make JavaScript more powerful, expressive, and easier to work with. Features like arrow functions, classes, modules, promises, and async or await have greatly improved the developer experience and the ability to write cleaner, more maintainable JavaScript code, keeping it relevant and modern. Learning JavaScript opens up a direct path to web development, which remains one of the most in-demand skill sets in the tech industry. Whether you want to be a front-end developer focusing on user experience, a back-end developer building server logic, or a full-stack developer doing both, JavaScript is an essential tool. Its reach even extends to mobile app development with frameworks like React Native and Ionic, and desktop app development with tools like Electron, further broadening its utility. The community around JavaScript is vast, active, and constantly innovating. Similar to Python, you'll find an overwhelming amount of learning resources, tutorials, libraries, managed by NPM, the Node Package Manager, which is the largest ecosystem of open-source packages in the world, and online communities ready to help. This vibrant ecosystem means that if you encounter a problem or need a specific functionality, there's a high probability that a solution or a library already exists, saving you significant development time and effort. In essence, if your goal involves building for the web, JavaScript is not just an option, it's a necessity. Its ability to create rich, interactive user experiences on the client side, coupled with its growing prowess on the server side via Node.js, makes it an incredibly versatile and powerful language. From simple website animations to complex single-page applications and robust back-end systems, JavaScript is the driving force behind the dynamic, interactive web we use every single day, making it a critical language for any aspiring web developer to master. Next up, we delve into Java, a language renowned for its robustness, platform independence, and widespread use in large-scale enterprise applications. Created by Sun Microsystems in the mid-1990s, now owned by Oracle, Java was designed with the philosophy of write once, run anywhere, or WARA. This means that Java code compiled on one platform can run on any other platform that has a Java Virtual Machine, or JVM, installed without needing to be recompiled. This cross-platform compatibility has been a major factor in its enduring popularity, especially in complex corporate environments. Java is a statically typed, object-oriented programming language which contributes to its reputation for building secure and maintainable systems. Static typing means that variable types are checked at compile time, catching many potential errors before the application even runs. Its object-oriented nature encourages modular program structure and reusable code, which is crucial when developing large, complex applications that need to be maintained and updated over many years by large teams of developers. These features make it a go-to choice for systems where reliability and stability are paramount. One of Java's most significant domains is enterprise-level application development. Think about the software that powers large banks, insurance companies, retail giants, and government organizations. Much of this critical infrastructure, including transaction processing systems, customer relationship management software, and supply chain management tools, is built using Java and its enterprise edition, Java EE, now known as Jakarta EE. The language's scalability, performance, and extensive ecosystem of mature libraries and frameworks make it well suited for these demanding applications. Another major area where Java dominates is Android mobile app development. While Kotlin is now also an official language for Android, Java was the original and, for many years, the primary language for building native Android applications. A vast majority of existing Android apps and a large code base of Android development resources are in Java, so if you're interested in developing for the world's most popular mobile operating system, learning Java provides a solid foundation and access to a wealth of established tools, tutorials, and community knowledge. The Java Virtual Machine, or JVM, is a key component of Java's architecture. It's not just an execution environment, it also provides features like automatic memory management through garbage collection, which helps prevent common programming errors like memory leaks. The JVM is a highly optimized piece of software, and many other programming languages such as Scala, Kotlin, and Groovy have been designed to run on the JVM, leveraging its performance and ecosystem. This makes the JVM itself a powerful platform beyond just Java. Java's standard library is incredibly comprehensive, offering a vast array of built-in functionalities for tasks ranging from network programming and database connectivity to graphical user interface development and XML parsing. This rich standard library, often referred to as the Java API, means developers can accomplish a lot without needing to rely heavily on external libraries for core tasks, though a massive ecosystem of third-party libraries and frameworks like Spring for enterprise applications also exists to extend its capabilities further. While Java's syntax can be more verbose compared to languages like Python, this explicitness is often seen as a benefit in large projects, as it can lead to code that is easier to understand and maintain in the long run, especially when many developers are collaborating. The strong typing and object-oriented principles enforce a certain level of discipline that can be beneficial for building robust, mission-critical systems. The learning curve might be a bit steeper initially, but the payoff is the ability to work on very large and impactful software. The performance of Java applications is generally very good, especially for long-running server-side applications. The JVM uses just-in-time or JIT compilation, which compiles bytecode into native machine code at runtime, allowing for significant optimizations based on the actual execution patterns of the application. This, combined with concurrent programming features built into the language, enables Java to handle high throughput and low latency requirements effectively. The Java community is mature, extensive, and well-established. You'll find a wealth of documentation, books, online courses, and active forums. Major corporations continue to invest heavily in Java, ensuring its continued relevance and development. While newer languages emerge, Java's strong foothold in enterprise systems and Android development, along with its continuous evolution, new versions are released regularly with modern features, means it remains a highly valuable skill for software engineers. In conclusion, Java stands as a titan in the programming world, particularly favored for its write once, run anywhere capability, its suitability for large-scale, complex enterprise systems, and its foundational role in Android app development. Its emphasis on stability, security, and performance, supported by the powerful JVM and a rich ecosystem, ensures that Java will continue to be a critical language for developers aiming to build robust, scalable, and mission-critical applications for businesses and mobile users worldwide for the foreseeable future. Let's now turn our attention to C++, a language that is synonymous with power, performance, and low-level control. If Python is the friendly diplomat and JavaScript the dynamic web artist, C++ is the master engineer, capable of building incredibly fast and efficient software by working very closely with the computer's hardware. It's an extension of the C language, adding object-oriented features and many other enhancements, but retaining C's ability to manipulate memory directly and manage system resources with fine-grained precision. C++ is a compiled language, meaning the source code is translated directly into machine code that the computer's processor can execute. This compilation process generally results in applications that run significantly faster than those written in interpreted languages like Python or JavaScript. This raw speed and efficiency make C++ the language of choice for performance-critical applications, where every millisecond counts. Think of high-frequency trading systems, complex physics simulations, or demanding real-time processing tasks. One of the most prominent domains for C++ is game development. Major game engines like Unreal Engine and Unity, though Unity primarily uses C# for scripting, its core is SPI+, are built using C++, and many AAA game titles are developed directly in C++ to achieve the high frame rates and complex graphics that modern gaming demands. The ability to manage memory meticulously and optimize code down to the hardware level is crucial for squeezing every bit of performance out of gaming consoles and PCs. Beyond gaming, C++ is fundamental in system software development. Operating systems, including parts of Windows, macOS, and Linux, as well as device drivers, embedded systems like the software in your car or microwave, and high-performance servers, often rely heavily on C++. Its capability to interact directly with hardware components, manage memory allocation and deallocation manually, and its relatively small runtime footprint make it ideal for software that forms the bedrock of our computing experiences. Learning C++ can be more challenging than learning languages like Python. It has a steeper learning curve due to its complex syntax, the need for manual memory management, using pointers and concepts like new and delete or smart pointers, and the sheer number of features it offers. Mastering concepts like pointers, memory allocation, templates, and the standard template library, or STL, requires significant time and effort. However, this complexity is what gives developers unparalleled control and power. The standard template library is a core part of C++ and provides a rich collection of data structures like vectors, lists, maps, and algorithms, such as sorting and searching. Using the STL effectively can greatly improve productivity and code quality in C++, allowing developers to leverage well-tested, efficient components instead of reinventing the wheel. Understanding the STL is crucial for any serious C++ programmer, as it forms the basis for much of modern C++ development. Object-oriented programming, or OOP, is a key paradigm in C++, allowing developers to create classes, objects, and use principles like encapsulation, inheritance, and polymorphism to build modular and reusable code. While C retains its procedural roots, C++ fully embraces OOP, enabling the development of large, complex software systems in a more organized and maintainable fashion. This makes it suitable for projects that require both high performance and sophisticated software architecture. Despite its age, it was developed in the early 1980s, C++ continues to evolve. The C++ Standards Committee regularly releases new versions of the language standard, such as C++11, C++14, C++17, C++20, and C++23, introducing modern features, improving safety, and making the language easier to use without sacrificing its core strengths. These updates help keep C++ relevant and competitive for contemporary software development challenges, addressing some of its historical complexities. The C++ community, while perhaps not as overtly beginner-focused as Python's, is vast, knowledgeable, and deeply experienced. There are countless resources, from classic textbooks to advanced online forums and conference talks, catering to all levels of C++ developers. For those willing to put in the effort, the rewards of mastering C++ include the ability to work on some of the most challenging and high-impact software projects in the world, from cutting-edge game engines to critical infrastructure software. In summary, C++ is the undisputed champion when raw performance, low-level hardware control, and system resource management are top priorities. Its dominance in game development, operating systems, embedded systems, and high-performance computing is a testament to its power. While it presents a steeper learning curve due to its complexity and manual memory management, the control and efficiency it offers are unparalleled, making it an essential language for developers tackling the most demanding computational tasks and building the foundational software that powers much of our digital world. Finally, let's talk about Ruby, a dynamic open-source programming language with a focus on simplicity and productivity. Often described as a language designed for developer happiness, Ruby's syntax is known for being elegant, natural, and easy to read and write, almost like a well-written prose. It was created in the mid-1990s by Yukihiro Matsumoto, who blended parts of his favorite languages, like Perl, Smalltalk, Eiffel, Ada, and Lisp, to form a new language that balanced functional programming with imperative programming. Ruby is a purely object-oriented language, meaning everything in Ruby is an object, even basic data types like numbers and strings. This consistent object model can make the language feel very intuitive once you grasp the core concepts. Its philosophy emphasizes making programming enjoyable and minimizing the cognitive load on the developer, allowing them to express ideas in code in a very direct and often beautiful way. This focus on elegance can lead to more maintainable and understandable code bases. The most famous association with Ruby is undoubtedly the Ruby on Rails framework, often just called Rails. Rails is a full-stack web application framework that follows the convention over configuration and don't repeat yourself or dry principles. It provides developers with a structured way to build web applications quickly and efficiently by making a lot of common assumptions and providing sensible defaults. Rails revolutionized web development in the mid-2000s with its emphasis on rapid development and has influenced many other web frameworks in other languages. Many successful web applications were initially built or are still powered by Ruby on Rails, including notable names like GitHub, Shopify, Airbnb, Twitch, and Basecamp, the company where Rails was created. These examples demonstrate Rails' capability to scale and handle complex business logic, making it a viable choice for startups looking to get a product to market quickly, as well as for established companies maintaining sophisticated web platforms. The productivity gains offered by Rails are a significant draw for many development teams. Beyond Rails, Ruby is also used for scripting, automation, and as a general-purpose programming language. Its clean syntax and powerful standard library make it suitable for writing utility scripts, similar to Python. There are also other web frameworks for Ruby besides Rails, such as Sinatra, which is a more lightweight micro-framework offering greater flexibility for smaller applications or specific API development needs. This shows Ruby's versatility extends beyond just the Rails ecosystem. One of the hallmarks of the Ruby community is its strong emphasis on testing and software development best practices, like behavior-driven development, or BDD, and test-driven development, or TDD. Tools like RSpec and Cucumber are very popular in the Ruby world, and help developers write robust, well-tested code. This culture of quality contributes to the reliability of applications built with Ruby and its frameworks, fostering good habits among developers who learn and work within this ecosystem. Ruby is an interpreted language similar to Python. This generally leads to a slower execution speed compared to compiled languages like Java or C++, but for many web applications, the development speed and ease of use often outweigh raw performance concerns. Moreover, with proper optimization and caching strategies, Ruby on Rails applications can handle significant traffic and perform very well. The focus is often on how quickly and pleasantly developers can build and iterate on features. The learning curve for Ruby itself is often considered relatively gentle, especially for developers who appreciate its expressive and almost English-like syntax. Getting started with Rails, however, can involve a steeper learning curve due to the number of conventions and magic that the framework provides. Once these conventions are understood, development can become incredibly fast, but initially it can feel like there's a lot to take in. The Rails magic refers to how much work the framework does for you behind the scenes. The Ruby community, while perhaps smaller than those for JavaScript or Python, is known for being very welcoming, passionate, and helpful. There's a wealth of gems, Ruby's term for libraries or packages managed by Ruby Gems, available to extend the language's functionality, covering almost any conceivable need. Conferences like RubyConf and RailsConf are popular events where a lot of knowledge sharing and community building happens, reflecting the strong collaborative spirit. In conclusion, Ruby, particularly when paired with the Ruby on Rails framework, offers a highly productive and enjoyable development experience, especially for web applications. Its elegant syntax, strong emphasis on developer happiness, and the convention over configuration philosophy of Rails allow for rapid development and the creation of sophisticated websites and services. While it might not be the first choice for raw computational performance, its strengths in building feature-rich applications quickly, supported by a passionate community and a culture of quality, make Ruby a delightful and powerful language for many developers and projects. Okay, so wow, that was a lot, right? We just speed-dated 5 whole programming languages. My brain feels a little bit like scrambled eggs, but in a good informative way. Hopefully yours does too. It's like Python is your super chill, versatile friend who's good at everything. JavaScript is the one making all the cool, flashy stuff happen online. Java is the serious corporate one building giant, important things. C++ is the intense, super smart one obsessed with speed. And Ruby is like the effortlessly cool, artistic one. It's a lot to take in, I get it. Honestly, the biggest thing is don't freak out about picking the perfect one right away. It's not like you're getting married to a programming language, you know? You can totally learn one and then be like, maybe not for me, and then try another. The cool part is that a lot of the basic ideas, like the logic and stuff, kind of carry over. So it's not wasted time, it's all just experience. Maybe think about what kind of stuff you want to build. Is it a website? An app? A game? That could totally point you in a direction. And remember, this is just my take, or David's take that I'm channeling. The best way to know is to just try one, dip your toe in, watch some beginner tutorials, write a hello world. It's a classic for a reason, and just see how it feels. Does the syntax make your brain hurt, or is it kind of clicking? That's probably the most important thing. So yeah, go explore, be curious, and don't be scared to just dive in. You got this. Or, you'll figure it out eventually. We all do. Mostly.